Hi everybody. So today's video is going to be about task 1.3, and in this video we're going to cover the following learning targets. I can identify if a sequence is arithmetic or geometric and support my reasoning. So again, we're trying to identify, which means determine whether the sequence is arithmetic or geometric. And then we're going to support our reasoning, meaning we need to explain our thinking as to why we made the choice that we did. The second learning target is I can identify the common difference or common ratio in an arithmetic or geometric sequence and interpret it in the context of the problem. Again, we are identifying, which means finding, the common difference or common ratio depending on whether the sequence is arithmetic or geometric. And today we're going to focus on just the identifying part. We're not going to work on interpreting it in the context of the problem just yet. Now, you may recognize these learning targets from our previous video, and that should make sense. We're working on the same thing that we did in the previous video. The difference is what information we're starting with here. In the previous video, in task 1.2, we were starting with either a table of values or a graph. In these sets of notes, we're going to be starting with a scenario. So we're going to read sort of a story about what's happening. From that scenario, we're going to make a table, make a graph, and then use some vocabulary to describe it. So let's read through the first scenario and see if we can identify some important information. Diana starts the year with 10 demon dollars and she earns 2 demon dollars each week. Now, if we want to turn this scenario into a table, we need to think about the labels of the table. So just like before, our labels are going to have inputs and outputs. You can determine the input labels by looking for the word each or per. So since we are earning 2 demon dollars each week, the input labels are going to be the number of weeks. Now, what are we actually measuring here? We're measuring how many demon dollars. So the output label would be the number of demon dollars. Now, in order to fill in the actual values in this table, we're going to need a starting number, and then we're going to need to know how to grow our number over time. So if I reread this sentence, it says Diana starts the year with 10 demon dollars. So she starts the year with 10 demon dollars, which is going to give me my starting number in the table. So the start of the year, I'm going to call 0. No weeks have passed yet. We're just walking in day 1 of school. It's been 0 weeks. I already have 10 demon dollars. Maybe I saved them from last year. Now she is going to earn 2 demon dollars each week. So if she earns 2 demon dollars each week, then that means that as I increase the number of weeks, the number of demon dollars should add 2. So to go from 10 to the next number, I would need to add 2, which would give me 12. Now that's how many I have after I've added 1 week. So week 1, I have 12. Week 2, I would add 2 again, which would give me 14. For week 3, I would add 2 again, which would give me 16. Now, I'm going to stop after 3. We could continue to make this table as big as we want, but I feel like 4 points here is enough to really see a pattern in what's going on. Now, if we want to take this table and translate it to a graph, just like a good table has labels, a good graph has labels. So since the input column is labeled number of weeks, the x-axis, or the bottom of the graph, is going to be labeled number of weeks. And just like the output label of the table is number of demon dollars, the y-axis is going to be labeled number of demon dollars. Now, we always have to think about spacing and making our graph spaced out evenly. Since the input numbers are 0, 1, 2, and 3, I'm just going to go ahead and count by 0, 1, 2, and 3 at the bottom. Now, the output numbers are 10, 12, 14, 16. If I count how many lines I have to work with here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I count by 1, then the very top of the graph will be 10, which is the lowest number I need. Instead, it might be a good idea to count by 2. So I would have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now I'm going to go ahead and graph my points. So the first point is 0, 10, which would be right here on the graph. Then I would graph the point 1, 12, 2, 14, and 3, 16. Now, based on what I'm seeing here, based on the fact that there is an addition pattern in the table and that the graph looks like a straight line, if I were asked to describe this sequence, I would say that this is an arithmetic sequence. Now, I could use a couple different ways of explaining my reasoning, but the reason that I'm going to give is the one that actually comes from the words here, because that's the new thing of today is how do we look at these words? The reason that I'm going to say this is arithmetic is because the pattern in the words is telling me that I'm adding to each time. And again, these words each time are really important because we want to make sure we're showing that this is a consistent pattern that happens over and over again. Now, as soon as I've determined that my sequence is arithmetic, I'm also going to know that I have a common difference. Those two things go together, they're like partners. And the common difference is how much are you adding or possibly subtracting? In this case, because I'm adding, I would say that the value is plus 2 because I'm adding 2 each time. Now let's follow this up with another scenario. It says the number of students who need to pay fees at the bookstore on the first day of school is 150. The number of students who have fees decreases by 15 each week of school. Now, in order to fill in this table, again, I need inputs and I need outputs. So my inputs are going to be, if I'm looking for how often I'm increasing each week, which means the inputs would be the number of weeks. Now, the outputs are going to be what am I measuring? Well, I'm measuring the number of students who need to pay fees at the bookstore. So I would say number of students. Now, it says that on the first day of school, 150 students need to pay fees. On the first day means no weeks have passed yet. So after 0 weeks, there are 150 students who owe fees at the bookstore. Now, in the words here, it tells me the number of students who have fees decreases by 15 each week. So that means that the number is going to go down, or in other words, I'm going to subtract each week. So after 1 week, I would subtract 15, and that would give me 135. For another week, I would subtract 15, and that would give me 120. For another week, I would subtract 15, and that would give me 105. Now again, my weeks are just going up by 1, so I would have 1, 2, and 3 here, and I could continue to make this table even bigger, but again, I think 4 points is usually enough to really see a clear pattern, so I'm going to go ahead and stop after 4 points here. Just like before, we're going to sketch a graph here, so we're going to need to label the x-axis, which should match the labels for the input column of the table, so I would say number of weeks. And we need to have the labels for the y-axis. So my y-axis should match the output column. So I would say number of students. Now in my x-axis, I need the numbers 0, 1, 2, and 3. So I would have 0, 1, 2, and 3. And in my outputs, my highest value is 150. Now, as we talked about before, we only have 10 lines here. So in order to get to 150, we need to count by something bigger than just 1. I'm going to go ahead and I'm going to count by 15. So I would have 15, then 30, then 45, 60, 75, 90, 105, 120, 135, and 150. The first point that I'm going to graph here is 0, 150. Then I'm going to have 1 for the input, 135 for the output, 2 for the input, 120 for the output, and then 3 for the input, 105 for the output. Now, based on this information, we can see that there's a subtraction pattern by reading the words. We can see a subtraction pattern in the table, and we can see that the graph looks like a line. So because of those three things, I would say that this is an arithmetic sequence. And my reason would be because the pattern is subtracting 15 each time. Now, we could also use the reasoning that the graph looks like a straight line, but I'm trying to connect my reasoning here to the original information I had. And based on the words, I wasn't sure that the graph was a straight line. All I knew was that I was subtracting 15 each time, so I'm going to go with that as my explanation. Now, as soon as I know that this is an arithmetic sequence, I also know it's going to have a common difference. And in this case, the common difference is that I'm subtracting 15 each time. For the next problem, it says a YouTube channel starts off with 17 subscribers. Each day, the number of subscribers triples. So we need to kind of think about what our labels should be. Just like before, it said we need to look for the word each or per to figure out how often we are increasing. Here it says each day. So my input labels are going to be the number of days. Now, what we're measuring here is the number of subscribers. So for my output label, I would say number of subscribers. It tells me in the instructions here that it's starting off with 17 subscribers. So it's not after a whole day. That's maybe just kind of the default number that we were starting with. So for 0 days, I have 17 subscribers. After that, each day, so when my days go up by 1, my subscribers are going to triple. Now let's think about what that word triples means. When I say that something triples, it means my value gets multiplied by 3. So 17 times 3 would be 51. 51 times 3 would be 153. And 153 times 3 would be 459. Now we're going to go ahead and make a graph. So just like before, we're going to include labels. In this case, the x-axis label, which matches the input label, would be number of days. And the y-axis label, which should match the output label from the table, would be number of subscribers. My x-axis, I'm going to be using just the numbers 0, 1, 2, and 3. My y-axis, it's going to get a little trickier. Just like before, we only have 10 lines, so I think the best way to do this is going to be to count by 50s. So if I count by 50, I would have 50, 100, 150, 200, 250, 300, 350, 400, 450, and 500. Now, if I graph my points, I have the point 0, 17, which is pretty close to the bottom here, 1, 51, 2, 153, and 3, and then 459. Now, based on the words, which tell me that I'm multiplying, the table where I showed my multiplication, and the shape of the graph, which is a curve and not a straight line, I can say that this is a geometric sequence. When I'm explaining my reasoning here, I'm going to go back to the words. The word triples told me I had a multiplication pattern by 3 each time. So here I would just say that the pattern is multiplying by 3 each time. And again, saying each time is what tells us that this is a consistent repeating pattern, so we need to make sure to include that part of our justification. Now, in this case, because it's a geometric sequence, we're not going to have a common difference. We call this a common ratio. And the common ratio is how much are you multiplying by? So we would say we are multiplying by 3 each time. For the next example, it says on the first day of sales, there were 400 students who still needed to pre-order their books. Each hour, the number of students who still needed to pre-order their books was cut in half. So let's start by figuring out our labels. When I see each hour here, it tells me that my input labels are going to be the number of hours because that's how often my value is going to change. So I would say here that the input label should be number of hours. And my output label is going to be, what am I measuring? I'm measuring the number who still need to pre-order their books. So the number who still need to pre-order. Now, it says here on the first day of sales, there were 400 students, and since this is increasing each hour, no hours have passed yet. So I would say 0 and then 400 here as my starting value. There were 400 students. Now, each hour, the number of books was cut in half. So cut in half means that we multiply by 1/2, which means the next number here is going to be 200 after 1 hour. After 2 hours, I would cut that number in half again, which is 100. And after 3 hours, I would cut that number in half again, and I would get 50. Now, once again, I'm going to label my axes. So the x-axis should match my input labels, which is the number of hours. And the y-axis should match my output labels, which is going to be the number who need to pre-order. For my x-axis, it's pretty easy to figure out spacing because I'm just using the numbers 0, 1, 2, and 3. So I would label 0, 1, 2, and 3 here. For my y-axis, I need my numbers to get as big as 400. So I'm going to go ahead and count by 40s. So I would have 40, 80, 120, 160, 200, 240, 280, 320, 360, and 400. Now I'm going to graph my points. 0, 400, 1, 200, 2, 100, 3, 50. Now, based on the words that we used, cut in half, based on the table that we made where we saw there was a multiplication pattern, and based on the graph, which is shaped like a curve, I would say that this is another geometric sequence. It's just a decreasing geometric sequence. The numbers are getting smaller. My explanation would be because the pattern is multiplying by 1/2 each time. Now, again, I could explain this several different ways. I could say because the graph is a curve, I could say because the pattern is multiplying by 1/2, but I want to go back to the original instructions, which were just the words up here. So the key words in here were cut in half. I want to include that in my explanation. For common difference versus common ratio, as soon as I know that this is a geometric pattern, I can say it's definitely going to have a common ratio. Those two things go together. And the value is, what are you multiplying by? I'm multiplying by 1/2 because I'm cutting my numbers in half each time. For the next example, it says Samantha is practicing for a recital. On the first night, she practices for 5 minutes. On the second night, she practices for 15 minutes. And on the third night, she practices for 25 minutes. On the sixth night, she studied for 55 minutes. Now, this is where we're going to get into explaining the meaning of the common difference or the common ratio in the context of the question. So in the previous examples, we were really just focused on identifying the value. Here, we're going to really think about the meaning of what that means. So the first thing to decide is, do we have a common difference or do we have a common ratio? And the strategy that I would suggest that you use here is to make a table of values. If I read through this scenario, it says the first night she practices for 5 minutes, the second night she practices for 15 minutes, the third night she practices for 25, and then we skip a couple nights and we've got the sixth night is 55. That tells me that I could make a quick table that shows this relationship. So what night is it and how many minutes did she practice? And making this table is a great strategy for figuring out if it's arithmetic or geometric sequence, and whether that would help us determine if we have a common difference or a common ratio. So on the first night, she practices for 5 minutes. On the second night, she practices for 15 minutes. On the third night, she practices for 25 minutes. And because there's a bit of a gap here, on the sixth night, she practices for 55 minutes. Now, if we look at our pattern, based on the pattern in this table, I can see that the output values are increasing by 10 each time. That tells me that this is an arithmetic sequence, which means we have a common difference, and the value of that common difference would be plus 10. Now, when we're explaining our meaning, we need to say, well, what does the plus 10 represent? When we say we're adding 10 what? A couple important components here. We need to make sure we explain what it means, and we need to give units. So is it 10 hours, 10 days, 10 minutes? What is it? To explain the meaning here, I need to go back to what I'm measuring. I'm measuring the number of minutes she practices, and that's the column I see the pattern in. So I would say the number of minutes of practice. So what am I measuring? I'm measuring the minutes, the number of minutes in practice. What is happening to that minutes? We're going to say increases, meaning it's getting bigger, by 10 minutes. And then how often does that happen? Every night. So we would say each night. Now, these three components are what we need to include in all of our explanations. What are we measuring? How much does it get bigger or smaller by? How often does it do that? So I like to think about this as what is happening, how much is it changing, and then how often is that happening? This idea of what are we measuring, how much is it changing, and how often is it happening is the guidelines that we're going to follow for every interpretation that we do when we're interpreting whether the common difference or the common ratio. For the second example here, it says a basketball bounces off the rim of a basket that is 10 feet high. On the first bounce, it is 5 feet high. On the second bounce, it is 2.5 feet high, and so on. Again, before we determine whether we have a common difference or a common ratio, I think it's really important to make a table of values so that we can see the pattern. So we're counting the number of bounces, and we're measuring how high the ball bounces. So when it first hits the rim, so no bounces have happened yet, it's 10 feet off the ground. After one bounce, it's 5 feet off the ground. 2 bounces, it's 2.5 feet off the ground, and so on. Means this pattern continues. Now, if I think about what's happening here, at first I might think, oh, I'm subtracting 5, but 5 minus 5 should be 0, not 2.5. So another way to think about this is that we are dividing by 2, or in other words, multiplying by 1/2. Half of 10 is 5, half of 5 is 2.5. Because the pattern here is a multiplication pattern, I would say this is a common ratio, and the value is times 1/2. Now, to explain the meaning, we're going to follow the same 3 steps. First of all, what are we measuring? We're measuring the height of the bounce. So we would say the height of the bounce so what are we measuring? We're measuring the height, is doing what? How much is it changing by? We're going to say is cut in half, or we could say multiplied by 1/2. You could say either one of those things. And finally, how often? We would say each time it bounces, because that's how often we're changing. All right, everybody, thank you so much for watching, and I look forward to seeing you soon.